In this tape, we will get some more practice in setting up and solving a variety of word problems. You do not have to copy the problems off the board. You can get a copy of these problems from the attendant in the lab. Okay, so make sure you have your sheet with the problems before you start the tape. Okay, our first example. Joan puts some money in a bank account which pays 6% interest per year. She also has $5,000 more than this amount invested in a bond with an annual yield of 8%. If her total annual income from these two investments is $820, how much is invested at each rate? Okay, let X equal the amount invested at 6%, or the number of dollars invested at 6%. Amount invested would be fine, because in this particular problem, everything is clearly in dollars. Okay? Sometimes you should be very specific, okay, about your units if you have a problem with dollars and cents, say, mixed up. X is the number of dollars invested at 6%. Okay, now we are told that she has $5,000 more than this amount. That is $5,000 more than X invested at 8%. So X plus 5,000, this is the number of dollars invested at 8% in the bond. Okay, a certain amount at 6% and 5,000 more than that amount invested at 8%. Okay, now we are told the total interest from the two investments is $820. Okay, that is the interest from the 6% account plus the interest that she gets from the 8% bond. Together, this is her total annual interest from these two investments. Now we are told that the total annual interest from the two investments is $820. We will assume everything here is in dollars. This is the interest in dollars here too, and the total annual interest in dollars. We won't need dollar signs in our equations. Okay, the total annual interest is $820. This is found by adding up the interest that she gets from the 6% account and the interest from the 8% bond. Now, if you want to figure out the interest, you're going to take the rate times the amount that's invested. It's all here for 1 year, so we don't have to worry about that. Ordinarily, we'd have to also worry about the time element, but here we're talking about 1 year for all the investments. So it's simply taking the amount invested. Okay, if you want to figure out your interest, you take the amount invested times the interest rate for the time for the 1 year, if it's for a whole year. Okay, the interest from the 6% account would be 6% of the amount invested in that account, and the amount invested at 6% is X dollars. The interest from the 8% bond, it's the amount invested at 8%, which is X plus 5,000, times the interest that the bond is paying. Okay, X dollars invested at 6% times 0.06. This is 6% here, written as a decimal. This gives us the interest from the 6% account. The interest from the 8% bond, the amount invested in the bond, which is X plus 5,000 times 0.08, gives you the total annual interest in dollars. Okay, now, rather than working with an equation that has decimals like that, it would be convenient if we first were to clear the decimals. We will multiply both sides of this equation by 100 to remove the decimals. Remember, this is like having 6 over 100. Okay, 0.06 is 6 over 100. 0.08 is 8 over 100. If you had a fractional equation, you would multiply through by the LCD, okay, to clear the fractions. And the same thing here. If you multiply by 100, this 6 over 100 would just give you the 6. The 8 over 100 would give you the 8. So let's do that. 100 times 0.06x plus 100 times 0.08 times x plus 5,000 equals 100 times 820. We multiplied both sides of the equation by 100. Okay, and every term in the equation has to be multiplied. We have to multiply this term by 100 and also this term by 100 and the right-hand side by 100. Okay, now 100 times 0.06 gives you 6x, plus 100 times 0.08, that gives you 8, times x plus 5,000 equals 100 times 820 gives you 820 with 2 extra zeros because you're multiplying by 100, and that gives you 82,000. Okay, don't make the mistake of multiplying the 0.08 by 100 and also putting 100 in here. Okay, you do not distribute the 100 through these parentheses. Remember, a times b plus c. Here you distribute. A times b plus a times c. Okay, but if it was a times b, okay, a times bc, this is ab times c. It's not ab times ac. Okay, the 100 gets multiplied by the 0.08, and that's it. And then you multiply the result. That's the 8, and you multiply the result by the x plus 5,000. Okay, back over here. Let's solve this equation. We have 6x plus, now distribute the 8, 8x, 8 times 5,000 giving 40,000 equals 82,000. That's 14x plus 40,000 equals 82,000. Subtracting 40,000 from both sides, we get 14x equals 82,000, take away 40,000, that's 42,000. Dividing both sides by 14, x is equal 14 into 42 goes 3 times, so you get 3,000. So x is 3,000. Therefore, $3,000 is invested at 6%. $3,000 at 6%, because x is 3,000. And $5,000 more than that amount invested at 8%. So if 3,000 is invested at 6%, we have 3,000 plus 5,000, 8,000 invested at 8%. 8,000 invested at 8%. Okay, now the 3,000 invested at 6% gives us an interest. This is the answer to the problem. Now we want to check our answer in the words of the problem. Okay, the question was how much was invested at each rate. We have found that. Now let's check it. She has $5,000 more invested at the 8% than at the 6%. $3,000 invested at 6% would give an interest of $180. And then the $8,000 invested at 8% would give an additional $640 for a total of the $820 that we had on the problem. Okay, the total annual income from the two investments, $820, so we have solved the problem. Okay, now this is a distance problem. There is an entire videotape devoted to distance problems, but this particular distance problem gives rise to a fractional equation. Okay, you're a little further in your study of algebra now, and you can handle things other than, say, first-degree equations, linear equations. Okay, so this one gives rise to a fractional equation. Okay, but the basic idea is still the same. In other words, we're still going to be using distance equals rate times time as our starting formula. Okay, we have two trains. One is traveling 25 miles per hour slower than the other. train B travels 1,000 miles in the same amount of time it takes train A to travel 800 miles. What are the speeds of the two trains? Okay, now it's possible in a problem like this the numbers are not too complicated, and it does come out to be nice answers, integer answers, so you could possibly figure this out in your head. Okay, you should avoid doing that. You should try to do it with the equation. First of all, in real life problems, the numbers don't come out nearly as nice as this, so you really have to know how to do it. And also, no one's going to give you any credit on an exam by guessing your answers. You have to actually show the equations and work it all the way through. Okay, now the key in other distance problems that we have considered, very often they involve setting two distances equal to each other. For example, when one person overtakes another person. Here it's different. Here the things that are equal are times, the same time. Train B is going to travel 1,000 miles in the same time it takes train A to travel 800 miles. Okay, so the t's are going to be set equal to each other. Well, if d is equal to r times t, then dividing both sides by r, okay, it's clear that t is equal to d over r. And what we're going to do here is to say the time traveled by train, the time that train A travels is equal to the time that train B travels. They tell you that they're traveling the same amount of time. Now, time is distance over rate, so the distance traveled by train A over the rate, okay, that train A is traveling at is equal to the distance traveled by train B divided by the rate that train B is traveling at. Okay, let's see what we are told. We are told the distance traveled by train B, 1,000 miles, and the distance traveled by train A, 800 miles. Okay, now as far as the rates, we're not told them exactly, but we are told the train A travels 25 miles per hour slower than train B. Okay, so let's start here. Let's say let x equal in miles per hour. X will be the speed of train B, and then train A is 25 miles per hour slower than that, so x minus 25, okay, is the speed of train A in miles per hour. Train A travels 25 miles per hour slower than train B. So if x is B, 25 miles less than that, x minus 25 would be the speed of train A. Some people start by saying x is the speed of train A, in which case then x plus 25 comes out to be the speed of train B. The important thing is that there be a difference of 25 miles per hour in their speeds. Doesn't matter which one you let be x. Either x and x plus 25 here, or x and x minus 25 down there. So x is the speed of train B. And we're all set to substitute into our equation here. The distance traveled by train A over here, train A is traveling 800 miles. The rate that train A is traveling at, the speed of train A's rate is x minus 25 miles per hour. The distance traveled by train B travels 1,000 miles. The rate that train B is traveling at, train B travels at x miles per hour. Okay, so we have our equation. It's a fractional equation, and we have one unknown, x being the speed of train B. After we find x, we can then substitute and get x minus 25, the speed of train A, and that would solve the problem. The question being, what are the speeds of the two trains? Okay, over here we'd like to solve this fractional equation. What we do is we multiply both sides by the lowest common denominator, which in this particular case is the product of the denominators. Okay, so we will multiply both sides of the equation by x times x minus 25. Multiply both sides of the equation by the lowest common denominator, which is the product of the two denominators. On the left-hand side, the x minus 25s cancel, and we get 800x. And on the right-hand side, the x's cancel, and we get 1,000 times x minus 25 in parentheses. Okay, and now we solve the equation. 800x is 1,000x minus, now don't forget, distribute the 1,000 through the parentheses, 1,000x minus 25,000. And we get now subtracting 1,000x from both sides. $800x minus 1,000x, that's minus 200x equals minus 25,000. Dividing both sides by minus 200 gives us x equals now minus over minus, that's plus. Okay. We get 250 over 2, that's 125. And that's in miles per hour. Okay. Train B is traveling at 125 miles per hour. That's for train B. And train A, x minus 25. 125 minus 25, that is 100 miles per hour. So your answers, train B goes at 125 miles per hour, and train A at 100 miles per hour. Okay, and if you wanted to check this problem, you could see, well, train A, 100 miles per hour, covering 800 miles, he's traveling for 8 hours. Okay, train A is traveling for 8 hours. Okay, the time is the distance over the rate. Train A traveled 800 miles at the rate of 100 miles per hour, 8 hours. Okay, in the same 8 hours, train B, 8 hours times its rate of 125 miles per hour. When you multiply that, you get the 1,000 miles that train B was traveling. Okay, so the answers are correct. Okay, now we assume the merchant is a fair man. Okay, you could say, no, don't use any $8 candy. Okay, just take the 30 pounds of candy worth $3 a pound and start selling it for $5 a pound. Okay, we're trying to assume that the merchant is a fair man, and he really wants to take a mixture of the more expensive candy with the less expensive candy and come out with a fair mixture that is really worth, okay, as much as this is worth $8 and this is worth $3, a mixture that is really worth $5 per pound. He doesn't want to cheat the consumer here. Okay, we will let x equal the number of pounds of $8 candy to be used in the mixture. Okay, that's exactly what we're looking for. How many pounds of the $8 candy should be used? Okay. Now, if he is a fair man, then the value of the $8 candy, okay, this is in dollars, the value of the $8 candy in the mixture, the value of the $8 candy in the mixture in dollars, plus the value of the $3 candy in the mixture in dollars should be equal to the total value of the mixture, which is the value of the $5 mixture candy. You're going to put some $8 candy and some $3 candy and come out with a mixture worth $5. Now, the value of the $8 candy in the mixture. He has X pounds of $8 candy in the mixture. 1 pound would be worth, of course, $8. 2 pounds would be worth $16, and so on. X pounds would be worth $8x. Okay? He has a certain number of pounds of the $8 candy times $8 per pound. That's the value of the $8 candy in the mixture. Now the value of the $3 candy in the mixture. He's putting 30 pounds of the $3 candy in. Okay, so there's no unknown here. It's $3 a pound times 30 pounds. And the total mixture is going to be worth $5 per pound times the number of pounds. Now, the kinds of candy we have in this mixture, we have some of the $3 candy and some of the $8 candy. We have 30 pounds of the $3 candy and X pounds of the $8 candy. He takes X pounds of $8 candy, worth $8 per pound. That's the value of the $8 candy in the mixture. The $3 candy, he has 30 pounds of that. That's the value of that. The total mixture, it's X plus 30 pounds. Some of the $8 candy, some of the $3 candy. And he's going to sell it at $5 per pound. The question is, how much of the $8 candy should he put into this mixture? Try to find X for this to be a fair mixture. So 8X plus 90 is equal to 5X plus 150, distributing the 5 through the parentheses. Okay, let's subtract 5X from both sides. That gives you 3X plus 90 equals 150. Subtract 90 from both sides. 3X is equal to 60. Divide both sides by 3. X is 20. Okay, 20 is X, the number of pounds of the $8 candy that he should use in the mixture. Okay, 20 pounds of $8 candy. Then the 20 pounds of the $8 candy times $8 a pound, this is $160 of value, and 90, that's $250, and the mixture has 20 and 30, a total of 50 pounds at $5 a pound. That's the $250. The 20 pounds of the $8 candy. Okay, now there's a little bit of geometry in this problem. If you haven't, I'll go over the important ideas in case you haven't seen the geometry videotapes already. So we're talking about a right triangle. A triangle that has a right angle in it, that is a 90-degree angle. We're told one leg is 2 more than the other. Okay, so let X represent one of the legs of the triangle, and then the other leg would be 2 more than that. So that would be X plus 2. The hypotenuse, that is the longest side in the right triangle, the side opposite the right angle, that has length 10. Okay. Now you asked for the area of the triangle, but at the moment we're not prepared to find the area. The area of a triangle is 1/2 base times height. Okay, and in a right triangle, you can take one of the legs as the base and the other one as the height. So it's 1/2, in this case, X times X plus 2. But of course, we must first know what X is. Okay, and that's our first operation here. Now, to find X, we make use of the fact that in a right triangle, we have a certain theorem which is called the Pythagorean Theorem, which says that the sum of the squares of the two sides is equal to the square of in the right triangle is equal to the square of the hypotenuse. In a right triangle, the sum of the squares of the two sides, of the two legs, is equal to the square of the hypotenuse. A squared plus B squared equals C squared. In this case, X squared plus X plus 2 squared is equal to 10 squared. A squared plus B squared equals C squared. Okay, and we're going to solve this equation. It's going to give us a quadratic equation, which we've already studied. And we'll find X, and after we find X, we'll be able to go and get the area of the triangle. Okay. X squared plus, now X plus 2 squared is really X plus 2 times X plus 2. So using FOIL, we get X squared plus 2X plus 2X, that's plus 4X plus 4. First, outer, inner, last, equals 10 squared, which is 100. Combining the X squared terms on the left, we have X squared plus X squared, 2X squared plus 4x plus 4 equals 100. Let's subtract 100 from both sides of the equation. 2x squared plus 4x minus 96 is equal to 0. Okay, we have a quadratic equation. Everything on one side equals 0. We are going to solve this quadratic equation. You can try to, some people make the mistake of immediately trying to factor, okay, into two binomials. Remember, the first thing to do is to look for a common factor. And we notice that we can pull a 2 out from all of these terms, giving you x squared plus 2x minus 48. The problem is so much simpler if you first pull out that 2. Okay, so don't start looking for, factors of 96 and 2. Pull the 2 out. Then it becomes a very simple problem to factor. We want, since now the coefficient of x squared is 1, we want two numbers which multiply to minus 48 and add to 2. That would be plus 8 and minus 6. Checking this by FOIL, you get x squared minus 6x plus 8x. That's the plus 2x minus the 48. Okay, we have this product equal to 0. Okay, so at least one of the factors is equal to 0. Clearly, 2 is not equal to 0. In fact, you could have divided both sides by 2 to start off. So it wouldn't even be here. Okay, so 2 is not 0. Either x plus 8 is 0 or x minus 6 is 0. This gives you x equals minus 8. This gives you x equals 6. Since x represents the length of the side of a triangle, okay, we will reject the negative answer. Although x equals minus 8 is an algebraic solution to this equation, it doesn't make any sense from the point of view of the actual problem. X represents the length of this side of the triangle, and therefore we do not take negative length. Okay, so the only answer to this problem is x is equal to 6. Let's go back to the triangle. X is 6. The other leg, which is 2 more than 6, of course, is 8. This is a 6, 8, 10 right triangle, so 3, 4, 5 triangle doubled. Okay, now that we know the lengths of all the sides, we will be able to get the area here. The area is 1/2 base times height. The base is 8 units. The height is 6 units, giving us 48 divided by 2, or 24 square units. Or you can put the 2 into the 8, get 4 times 6, 24. So the answer to the problem, always make sure, in other words, don't stop here. Make sure you actually answer the problem. Find the area of the triangle. The area is 24 square units. Okay, so we're starting with a rectangle. Okay, we have a quadrilateral here. The opposite sides are equal in length, and we have the 4 right angles. So we have our rectangle. The length of a rectangle is 4 more than the width. So if we let the width be w, then the length is 4 more than that. The length is w plus 4. Okay, so let w equal the width, or the number of units in the width of the rectangle. And then w plus 4 is equal to the length of the rectangle. Okay, it tells you the length is 4 more than the width. Okay, now we're told that the area is 45 square units. Now in a rectangle, the area of a rectangle is the length times the width. Okay, so in our particular problem, the area A is L times W. That is W plus 4 times W. And we were told the area is 45, and we want to solve for W. Having found W, we'd be able to find length as well, which is W plus 4. So W plus 4 times W is equal to 45. The length times width equals the area. The length is W plus 4. The width is W. The area is 45 square units. Okay, let's distribute this w through the parentheses. W times w, w squared. 4 times w equals 45. Subtract 45 from both sides. Okay, w squared plus 4w minus 45 equals 0. Some people get confused and feel that they should be able to take the 45 away from the 4w in some better form. Okay, these are not like terms. You cannot combine these in any way other than just to list them all here. W squared plus 4w minus 45 is equal to 0. Now this is a very simple problem to solve by factoring. You'll notice that there are no factors in common for these three terms. What we're looking for are two numbers which multiply to minus 45 and add to 4. Okay, that would be plus 9 and minus 5. Let's check. You should always check your factoring. Let's check it by FOIL here. W squared minus 5w plus 9w, that's the plus 4w, and the minus 45. Always make sure it works, even to the extent that you have to have the minus 45. Sometimes people get the outer and inner to match, and the last term is wrong in the sign. Okay, the last term is minus 45, which is correct. The product of two numbers is equal to 0, so either the first of the numbers is equal to 0 or the second. This gives you w equals minus 9. This gives you w equals 5. For the reasons mentioned in the last problem, we will reject w equals minus 9. We cannot have a negative width for a rectangle. The only answer, therefore, is w equals 5 units. If w is equal to 5 units, then the length, which is w plus 4, 5 plus 4 becomes 9. We have the property that the length is 4 more than the width, and the total area, 5 times 9, gives you the 45 square units. Okay, so we've solved the problem. The dimensions are 5 by 9. The area is 45. And that brings us to the end of this tape.